So Omar, a lot of these words are like, can you hear me? A lot of
Can you hear me
these
now? Yes.
words are like new to me because like artifacts. So in dental,
Uh-huh.
when we had CT scans on patients, the artifacts were
Hmm.
things that were like discrepancies in the
Hmm.
scan. So all
Hmm.
this is to a lot of different, a lot of learning, which is really, I mean, it's really helpful for me. But I see one word and I'm thinking my mindset's going to health, and then I look it up and
Yeah.
it's a totally different thing. So
Wow. Wow.
a lot of relearning.
No, definitely, definitely.
Can't hear you.
I
I'm sorry.
can you hear me now?
Oh, yes, yes, I can hear you now.
Oh, great. Yeah. No, I definitely agree. I know it's been a real journey for me. My whole journey into CS was all on the heels of really just discovering coding and programming. And recently, I just graduated from the UCI teacher credentialing program in computer science. And
Mhm.
honestly, it totally stretched my mind in ways I never even thought it could be stretched.
Yes.
So, for example, one of the things I found most challenging in the beginning was understanding that when you have a variable and you assign it a value, that it doesn't always equal that. So in programming, you can change that variable, you can reassign the value. And that actually, I don't want to say killed me, but it really hurt me in the very beginning because in math, you like are ground in. This is what it is. And you have to kind of almost understand it conceptually. And it's one of those things that really inspired me to think about, hey, when you're in middle school and you're learning these concepts, understanding them on a conceptual level will really support you in being able to embrace, more rigorous or even like CS content, like we're talking about now later. And at the county office, one of the things that I've really been inspired by is looking at all these teachers who use these different tools to integrate CS into their work. So, for example, Josh Gagnier, he was really big about bringing in the Arduino into his physics classroom to begin helping the kids see some things through the lens of microcontrollers and programming. Now, that, of course, is a much more advanced level of access to physical computing, if you will, but it definitely gave the kids a sense of what they could do. And working with those students right there in Santa Ana, as he does, it really, I think, gives them access, I think, in ways that they may not have had without having an opportunity to do that. So it was really, really exciting to be able to see that.
Yes, it's wonderful. I know.
So I'm really thankful that everyone is getting on the call. We'll get started in just a moment. I will share, though you may already know, we do have the resources shared on the website. I tried to put it up, is it that way? On the URL there, tinyurl.com/OCDECSPD. It actually takes you to our OCDE website. And it's the site that we put together for computer science. I really had the honor of curating some resources there. And, one of the things we're going to be doing is visiting, several resources. What I'll do, though, is I'll just share my screen right now, because while we're preparing to get started, one thing we can do is share a little bit of what's on that website. I'll share with you a little quick trick. You can always type stem.ocde.us. That actually is a shortcut to our website, just stem.ocde.us. And by doing that, it'll always bring you to our STEM home, if you will, where you can access our different programs. Now, I do have the honor of serving alongside some amazing educators working in math and in science. And we're really excited to be able to collaborate. I, though, have the honor of leading on the event side, the Orange County Robotics Consortium. So if you have an interest in engaging your students in physical computing and competitive robotics, we're definitely going to be looking forward to host some information on that soon. And then further down, though, what we're talking about right now is the computer science page. So when you're brought right there, one of the interesting things are in the very beginning, right when we had to pivot to this stay-at-home order in the beginning and now this new paradigm that we're in, we did curate some distance learning resources around computer science. So if you were looking for something, maybe you wanted to find something to engage your students, we do have some things there. I happen to be an ambassador for CS for All Teachers, and we have links there for you. I happen to also be a facilitator for code.org. We also have some wonderful resources shared with one of our wonderful collaborative partners, Dreams for Schools, and they have some coding at home resources here that you can actually access on our website. And maybe what I'll do is I know I have an opportunity to maybe collaborate with them, bring them on, and we can give an opportunity to them on one of these sessions to be able to share up a little bit of what they're doing there with Dreams for Schools. But without further ado, what I'll do is I'll go ahead and click on my presentation, just because as we're into our time now, we want to go ahead and begin. One of the things I wanted to do is acknowledge that we had to have a little bit of a shift in our, I'm sorry, I moved this screen over here, a little bit of a shift in our schedule because, you know, we moved away from Python. We wanted to give everyone a chance to engage the learning with the resource we have with our friends from PopFizz. And I don't know about you, but I had such an exciting time engaging with the PopFizz and also responding to some of your prompts in the forum, really helping to expand our thinking. But today, we're going to have a quick talk on algorithmic thinking. Then we're going to have a little overview of the CS standards through the lens of the activity that we talk about. Then we're going to spend some time looking at some interactive, collaborative CS classroom strategies, and then we'll have a chat with our friends from PopFizz and dig into that. So with that being said, I'm not certain if you've seen this video before. I know a lot of folks have. I know they have. But for me, when my first journey into the space of talking about computer science, just like our friend Susie was just sharing, this may not be the word she's referring to, but there were all these words being used that I really didn't have any context for. One of those words was the word algorithm. I'm thinking, okay, I know algorithm from math, right? Understanding the algorithm, I'm not going to try to go off the hip this time, but what I found is that some of these words that we hear, algorithm, computational thinking, while they may have mathematical connections, right? We see those words because we hear those words in math, right? Words like variables, we see those words in math, right? This really, I think, elevates a true need to understand more about the conceptual understandings behind CS. I'm gonna just play this video really quick, give it a gander. We're not gonna play the whole thing because it is 7 minutes, but I think after the first iteration, you'll get a sense. All right, I'm gonna hit play now. Hopefully you'll be able to hear everything.
What's up, the internet? You know what, I'm hungry. I could really go for a peanut butter and jelly sandwich. Do you guys think you can write down some instructions and teach me how to make a peanut butter and jelly sandwich?
Yeah.
Then do it.
I knew we were gonna do this. I heard Dad talking to Mom.
Choke yourself on my hand. Sometimes they do what you tell them.
Dad, I'm done.
Step 1. Get 2 pieces of bread out. Got 'em. Get a butter knife and get some PB. Take 1 piece of bread, spread it around with the butter knife.
No, Dad, with the peanut butter.
I'm just doing what it's
Dad, I'm done.
Step 1. Get 2 pieces of bread out. Got 'em. Get a butter knife and get some PB. Take 1 piece of bread, spread it around with the butter knife.
No, Dad, with the peanut butter.
I'm just doing what it says. It says take 1 piece of bread, spread it around with the butter knife.
Hold on.
Get some jelly, rub it on the other half of the bread.
No, Dad, open the jelly.
Well, it doesn't say to do that. Put the breads together on top of each other. Take a big bite. This doesn't taste like a peanut butter and jelly sandwich. Fail.
Yeah. Oh, yeah. Sorry, I had to make it extremely specific.
Oh, good. I'm starving. Take 2 pieces of white bread out of the bag. Take the lid off the jar of peanut butter. Get a butter knife and stick it inside of the peanut butter jar. With the knife, scoop a bit of peanut butter out
A bit,
of the...
that means like a lot.
A bit means a lot?
In my
Can you hear me now? Awesome, awesome. I pause it there because essentially the video goes through a series of iterations of you seeing the kids develop a series of algorithms, right? A series of steps to support them in accomplishing that task. So one of the things that I experienced in one of my first CS for All trainings was thinking about how can we support educators in developing an understanding of algorithmic thinking in a way that's accessible, right? So what was introduced was this activity here. It didn't involve bringing out a real robot. It didn't involve making a series of codes or test writing a syntax. It just involved you thinking of what would the steps be, right? So here it goes. Write a series of steps for a robot to find the words in the word search. The robot has the following rules. It can only look at one letter at a time in the grid. It can only compare to one letter in one word at a time. It can remember some things if you tell it to. Let's pause for a moment there. Maybe take a moment. You know, we're going to be brave here. You know, we don't necessarily need to write down all the steps, but if someone wouldn't mind, maybe this could be a collaborative thinking activity. Where might a robot begin if a robot were to do that, given those rules? I'll give you a moment to ponder that. And if you were invited to share a thought or write something in the chat, if you'd like. Top left, okay. Now is top left the starting point? So hovering my mouse here, top left. Oh, it's a starting point, okay. So we can look at one letter at a time. It can only compare to one, I'm sorry, I'm looking at too many screens. One letter and one word at a time, and it can remember something if you tell it to. It's pretty interesting. Well, I definitely think this is an interesting activity. And one of the challenges in this type of activity is really not falling into a space. There was a term we used earlier where you're ending up in a, pedagogy of poverty mindset. So here is an example of an activity that maybe we can think about ways we can support students in being able to solve this problem, maybe by engaging in a couple of physical activities. Now, in the graphic I showed yesterday, admittedly, it was an amazing day, but it was the last day before we closed up and had to go stay at home. The goal was to be at school working with fourth graders, right, to support them in understanding about concepts of perimeter and area through the lens of working with this robot. And the whole idea was, if given a challenge, how would you program this robot to navigate the perimeter, for example, of the desk that you're at? Very much analogous to this, right? They're looking at where they are, they're thinking of what those steps might be, and they're coming up with that. And it is that iterative process that they go through. I do want you to know, though, that that activity was able to be articulated, or rather connected, through the lens of the California K-12 computer science standards. So if it were grade 2, right, people follow and create processes as part of daily life. Many of these processes can be expressed as algorithms that computers can follow. Grade 5, different algorithms can achieve the same result. Some algorithms are more appropriate for a specific context than others. You know, that actually makes me think of the term algorithmic diversity, right? Maybe we'll talk about that more. Not right now. In grade 8, that would consider that algorithms affect how people interact with computers and the way computers respond. People design algorithms that are generalizable to many situations. Algorithms that are readable are easier to follow, test, and debug. Now, there's a concept in programming that's often used. That concept is called modularity, right? And that idea is, how might you reuse a specific module within a series of programs over and over and over again? Thank you very much. All right. So, and then come grade 12, that would be grade 12, people evaluate and select algorithms based upon performance, reusability, and ease of implementation. Knowledge of common algorithms improves how people develop software, secure data, and store information. Now, a lot of these concepts are things that are all embedded within the California K-12 computer science standards. Collaboration, developing abstractions, testing and refining, communicating, right? That was all within this one activity, right? Now, while we won't go into great depth into all of the nuances of the California K-12 computer science standards, I at least want to take a moment to at least speak to each of them by naming them, right? There are core concepts and core practices of the California K-12 computer science standards. Here's where I think is an opportunity to maybe dispel a myth. You know, these standards were developed for teachers by teachers. What does that mean? That means that teachers across the state of California in English language arts, in math, in science, in social studies, all came together in early childhood education, joining the team, and thought about what are the best ways that we can identify what are those elements within the needs of computer science that we can create standards around to support students in being able to have a meaningful experience, right? That is computing systems, networks and the internet, data and analysis. Often the only thing people think about when they think about computer science is algorithms and programming. And the one that we've been talking about all week, the impacts of computing, right? And then there are the core practices that are around that. Fostering an inclusive computing culture. Let's pause there. Let's acknowledge that that's written in the standards, right? A core practice is fostering an inclusive computing culture. What might that look like? There's a video that I was reminded of by one of the comments in the PopFizz forum. If you have a chance, go check it out after we're done today. It was on algorithmic bias. It was an amazing TED Talk. You can check it out. I encourage you to take a look at it there. Okay, let's keep going. The other core practice is creating computational artifacts, collaborating around computing. That's what we're doing right now as we talk about the ways in which we can design these algorithmic solutions. Testing and refining computational artifacts, right? That artifact might be represented by that program that we created. That is an artifact that is demonstrating how we're solving that, right? Communicating about computing, recognizing and defining computational problems, and developing and using abstractions. Now, we won't go through a read of all of these practices, but know in the activity that we engage in, and when we're thinking about computational thinking, right? Practices 1, 2, and 7, the ones that we just read, right? Those are ones that really support computational thinking, as well as practices 3 through 6 supporting computational thinking practices. They're all delineated for you here. This is all a slide that you can access on our presentation, and you can look at it further. And essentially, when thinking of a lesson and how that is designed, and tomorrow we'll talk a little bit about lesson planning, right? We're thinking of the practice, the concept, and how that equals the standard, right? So right now, I wanted to at least spend 1 minute orienting you with what's on this page. There is a lot of links here. And I want you to know it's all information that's curated on our website. But I have it here for you for quick access. The first thing is are California K-12 computer science standards. Now, when looking at these standards, for those of you teachers thinking, gee, this is just another thing, what might I do? I want you to know they've got some really cool things here. One of them is the descriptive statements. Let me ask anyone in the room, put a grade level in the chat so I can scroll to that area so I make it relevant to our conversation. 5th, okay, I'm gonna scroll down. Just a moment here. Clicking on this, and this is all linked on the presentation. Just a moment, please. I'm gonna go left here. All right, and we're gonna go down with it. All right, 3 to 5, okay. Just to share, they are broken up in K2, 3, 5, 6, 8, 9, 12 bands. So 3, 5, this here is impacts of computing, right? IC number 20, discuss computing technologies that have changed the world and express how those technologies influence and are influenced by cultural practices, right? Let's read the descriptive statement for that. New computing technologies are created and existing technologies are modified for many reasons. Now, let's talk about what that might look like, right? For example, students could conduct research in computing technologies that impact daily life, such as self-driving cars. They engage in collaborative discussion describing impacts of these advancements. Self-driving cars could reduce crashes and decrease traffic, but there is a cost barrier to purchasing them. You'll see it's connected to the Common Core, state standards, and ELA and literacy, and the ones listed there. And there's also an alternative statement there for another way that it could be observed. I want you to know that this is actually just one of them. I'll go to one more because there's so much here. We could almost spend a whole hour exploring this. Let's go to 912. I want you to know in 912, it's a little bit different. So let me pause for a minute. Let's click back on the presentation. I'm sorry. Okay. So the presentation has our progression chart. The progression chart helps you kind of understand how this is progressing through the grade levels. Now, this is an extract, so I didn't have to download a document on the Zoom, but if it were downloaded properly here, you would see that the K2, 3, 5, 6, 8 bands, right? But when you get to the 9 through 12 level, it's broken down in core and specialty areas. That is to say that we understand that not all students will become computer scientists, but we believe that by having all students engage in CS curricula opportunities, CS engagement, CS learning, it'll support them in being more well-rounded and able to enter into life and career much more prepared for the future. And unfortunately, this is not downloaded. I don't want to spend too much time on it, but let's just read one really quick. 912. This one here is in the area of CS. That stands for computing systems, right? Describe ways in which abstractions hide the underlying implementation of computing systems to simplify user experiences. Now that does sound really complex, but I want you to know in the standards, there is a descriptive statement that will help you understand a way that you can implement something like that, right? So looking here, this may not be the same standard, but just to emulate, right? Develop guidelines that convey systematic troubleshooting strategies that others can use to identify and fix errors, right? So therefore, an example would be students could create a list of troubleshooting strategies to debug network connectivity, et cetera, et cetera, et cetera. So we'll pause there on that, but I do want to share that within this page are all of those resources. So feel free to go back and give it a gander, because as we think about how we're going to engage our learners, right? What we're going to be engaging them in, that is seed, that is food for thought for ways you can A, implement CS in ways that are already a part of what you're doing, not just another thing, but an additional focus or augmentation that allows students to have access to CS, right? But how might we do that? Now this, I want to give full credit. I was inspired at the CSTA conference with additional resources for tools to encourage interactive, collaborative classrooms. Now we're going to try something different here. We're going to do a rapid review, share communication in a Google form. We're going to do that in a breakout room, and we're going to do a rapid breakout room switch, right? Let's see what that looks like. Thank you very much. All right. So currently, as we think about ways we can engage all learners, a lot of what we're talking about is active learning, right? And there's a lot of ways we can think about active learning by thinking about it through the lens of different structures we can observe in the classroom to support students with things like peer instruction. And there's a link there directly to that resource for you to take a look at on the presentation. Peer-led team learning, a wonderful opportunity for you to be able to support students in collaboratively learning together, right? This is a little different from project-based learning, right? As we think about it through a computer science lens. Problem-based learning, right? What might be a computational problem that we can support students in collaborating and solving, right? Process-oriented guided inquiry learning, POGIL. Actually, the one we're going to be exploring more today, and team-based learning. So let's take a look at what this is going to look like. Now, I'm really being brave here because this is going to require some finesse of the Zoom space, but I'm going to do my best. We will rotate among 3 virtual stations. Each station will have resources for you to review. So get ready because this next half hour is, well, it's going to go really quick. And then what we'll do is, let's just show you. The first group you'll be in will be discussing tools for pacing classroom activities, right? The next group you'll be in will discuss strategies for helping teams to report out, right? The next group you'll be in will discuss team member roles and role cards. And then we'll come back and we'll do a debrief, right? So essentially, it'll be 5 minutes in each of those rooms, and then we'll pop out another group, and then we'll pop out another group. So essentially, though, remember, you're going to have 5 minutes for discussion in your room. So we're going to try to move quickly so we can be able to pop through that. Now, I know I want to do my best to acknowledge space for questions. Might you have any questions? Please do share in the chat, get on the speaker and share. So I will share when you get on each slide, there is a link on that slide to that toolbox. It's going to take you to a Google form that will review the tool and give you a prompt to respond to. Okay. All right. So we'll go now. We'll first begin with, I'm going to hit pause here. We'll first begin with Collaboration Toolbox A. I'm going to open up the breakout rooms now. Give me one moment. Thank you. We'll do 5 breakout rooms. I'm creating the rooms now. All right, thank you. No, since we have to hit, do you think I should ask for feedback now on each one? Because it might be too much information to debrief at the end. I might just give them. Welcome back. All right. So thank you very much, everyone, and welcome back to, we're all back together. I want to just maybe give us at least 60 seconds for any thoughts, anything you might want to share as you consider the collaboration tools for strategies for, I'm sorry, I'm on the wrong slide. team member roles, and that's the wrong slide again, sorry. Tools for pacing classroom activities. Thank you very much. Any thoughts? Anything you want to share? Please feel free to type it in the chat or cut on the microphone.
I'll share something, Omar. It's Rochelle.
Oh,
Hi,
thank you.
I know I use the timer a lot, just in a general sense of, okay, here's 20 minutes, you know, be done by the end kind of a thing. But I thought it was very interesting how many different timing type things and how many of our kids in our groups might actually need those different types of pacing things. And especially for those groups that do work ahead, because, you know, there's always the kids who,
Right.
There's that one group that got finished in 4 minutes. And then there's
Right.
the kids who took, like, you're like, oh, are you done yet? We got to move on, you know? So I really like how there's those pacing and there's all those different ones. So I'm interested to use that. I don't, maybe not this year, obviously, but when we're back in the classroom and things like that. So.
Indeed, indeed. Well, thank you so much for sharing. I really appreciate that. What we're going to do now is shift into Toolbox B for strategies for helping teams to report out. Now, I've done my best to resort the rooms. I just did it automatically. It seemed to have worked. So we're going to go ahead and open up those rooms now, and I look forward to hearing your feedback. All right, thank you very much. See you soon. Chat, maybe one key takeaway. I know one thing that we always want our students to do is to find a way to share out, to communicate, to, you know, let us know what they're learning. And we got a lot of different ways to look at strategies for teams to report out. What were your thoughts? Any key takeaways? You can also feel free to share out audibly if you're inspired to share.
Hi, Omar. This is Mary.
Oh, hi.
So I was thinking that having some reporting out strategies ahead of time and rehearsing them with your students really helps keep students accountable. So you can't really have that one student hiding in the corner. You need that collaborative process and having all students be able to share and participate.
Wow. Well, no, absolutely. Absolutely. One of the things that I've seen helpful in those situations, especially working with students that might have any diverse needs, is maybe having that template that will literally say, you know, a statement where they literally are filling in the blank with their words as a model for them to be able to communicate and see how to do that. And that's being as educators to model that for them as well. Here it says in the chat, really have to think about your goal to decide which type of sharing and reporting you should do. Absolutely, absolutely. I think what's interesting about Rochelle's comment is, I'm sure we've all experienced when a share out might actually take away from the learning or take the learning in a different direction or create a need for you to pause and clarify to make sure students' conceptualization isn't somehow misconstrued or affected by any misconceptualization. So anyway, thank you very much for that. We're moving on to our last review now. We're going to probably have to shorten this one a bit just because of time. It is about 3:47. So we'll give us 5 minutes for this review. I'm going to put you in the breakout rooms now, and then we'll come back. All right, I'm going to set that up right now, just a moment. And recreate the rooms, because it does it automatically. Okay, and open all rooms. All right. Thank you, thank you, thank you. I'm hopeful everyone had a positive experience reviewing those strategies. Literally hot off the presses from the CSTA, the other CSTA, that's Computer Science Teacher Association, as it's always confused with the other CSTA. But I think CSTA's changed their name now. And those of you that are members of the other CSTA, that's the California Science, they're now a new name. So I don't think we'll get that confused that much anymore. So with that being shared, I'd like to pass it over to our friends from PopFizz to guide us through what we'll be doing as our homework as we go through this afternoon's activities. Thank you.
Yes.
Jane?
Wait, Omar, I'm sorry, can I interrupt
Yes?
really fast, really quick?
Yes.
Are these actual cards other than in the form, are these available to us with all that information from all 3 breakouts?
No, it's all on the presentation. You can click on it there, and essentially it's an image. And if you click on the POGL, for example, the link on the presentation will take you right to the CS POGL website where you can get that stuff too.
Awesome.
Sure, absolutely.
Thank you.
Sure. All right, thank you.
Yes. Omar, could you let me share my screen?
Oh, absolutely. I'll make you the
So
co-host. Absolutely. Jane.
So we've noticed that a lot of folks joined us yesterday. So those of you who still don't have access, you can join the class by using the link that I just pasted in the chat window. So please make sure to sign up. And I am now going to share my screen and go over some of the stuff that we went through yesterday very briefly, and then we'll jump to the course right away. So we are on day 3, which means that we're going to be learning HTML and CSS. And I know that many of you may already be familiar with this, so I hope you breeze through it. And on day 4, we're going to get a little more code heavy, roll up our sleeves, and go into JavaScript programming. After that, then we'll be going into the Teachable Machine, which is a Google created AI that you can teach to have it distinguish different things by looking at images, looking at your poses, or your sound that you teach. So we're going to be going through these things for the next 3 days, including today. And so here is the course. And so on day 2, we've noticed that there was a little bit of a display glitch for the blocks tool here, where the instructions were cut off a little bit at the bottom. We were able to fix that. So if you had trouble with that, we apologize. It should look okay now. So if it still looks a little funny, please refresh your window. And so that will be fixed for you there. And day 3, we're going to get into HTML and JavaScript, CSS. And there is an editor that you can use to create your code here. And I wanted to show this to you very briefly. So if your screen is a little small and you want to use the whole space, just click on this content icon at the bottom left side corner. It's going to then tuck away the menu, and you'll be able to use the whole screen like this. And all you have to do is type in your code and then run, and you'll see the result in the tiny window on the right side. If you actually want to see this in a bigger window, you can click on this gear icon and then open it in a new browser. So then this will show you the code that you just created. So one tip there, and make sure to submit. And once you do that, you'll get to go on to the next assignment. And yes, so keep doing that until you hit the last one, which is going to ask you to create your own HTML and CSS page. And if you ever get stuck or would like to look something up, there are step-by-step tutorials embedded here under these bubbles. So just go through it. And yes, so this will be your assignment for the day. And then tomorrow we're going to make an interactive website that's going to be a little more fun. And that will be done by using JavaScript. And thank you everyone who's posted in the forum. So we'll be looking through to answer any questions if you have. So thank you so much for posting all the great stories and your ideas and what worked in your classroom. It's going to be helping out a lot of teachers that are joining us at this point. All right, so that is that for the day. And tomorrow we're going to be talking about how JavaScript works and also some of the algorithmic biases that are out there. There are really interesting stories, and I don't know if you're familiar with the 2016 incident with Microsoft AI. Microsoft created this AI and trained it to learn about humans and human language using Twitter as the data source. And it turned out they created this Nazi machine. And you can read about that. Just do a little search there, Microsoft AI disaster, and you'll see it. Anyway, so yeah, we'll be looking at these interesting stories tomorrow. And that is it for today. And if you have any questions, you can ask right now, or I can follow up tomorrow. One more thing that I wanted to make sure I get out there is that I noticed that a lot of the teachers initially thought that this was going to be Python programming course, and I apologize for making the last minute switch. So we decided to open up our 5-day Intro to CS with Python PD course for everyone who's in this session right now. And we'll send out the course code that you can use to join. And so we'll invite you to that course also. All right. Well, thank you so much.
That's awesome. That's awesome.
Yeah, and I'll pass the mic to Omar to wrap it up.
Well, hey, I'm so humbled for this opportunity. I'm so excited to be able to share up my passion for CS, as well as the ways in which we can engage all learners. So I hope you enjoy your time in PopFizz. I look forward to seeing you tomorrow at 3. Have a great day now.